Hello, my name is Alexia Udol, and today I'm going to present to you Lab 4, Oscillations from Physics 2211. The purpose of the lab was to compare the predicted and experimental motion of a spring mass system in the x and y direction and plot the energy changes of the predicted motion of the spring mass system. Here are the physics principles that were used during the lab, and in the results of the lab, we will be able to see that our experimental data was similar to our computational data, but had some discrepancies in the y direction more than in the x direction. Also, the change in energy of the system is zero, which will be explained further on in the lab. Here you can see the main formulas that were used in the lab and to build the computational model. The initial conditions from the computational model were obtained through the experimental data from Tracker. In order to find K, the spring constant, and L naught, the relaxed length, these equations had to be used. However, we used the spring constant and relaxed length from pre-lecture video number 52. For Newton's second law part of the lab, we specified that the forces acting on the system are the spring force plus the force of gravity. For the energy principle part of the lab, the system is the mass plus the spring plus the earth and nothing in the surroundings. This means that the change in energy of the system is supposed to be zero. This is a video of my tracker. You can see that the spring mass system is moving in a lot of directions, not only up and down or side to side. The x and y positions of the mass were calculated and gave the resulting graphs. Here is my glow script model, and the first things that had to be done were to update the initial conditions. Here we have the mass of the object, which is 0.402 kilograms. The object's position and velocity, which was obtained through our experimental data from Tracker. Here we have the gravitational constant, which is 9.8, our spring constant, and relaxed length, which was obtained through pre-lecture video 52. And here we updated some of the conditions for the spring. We calculated L, L hat, and S. And here for the part of the energies of the model, we updated the formulas of the kinetic energy, gravitational potential energy, and spring potential energy. And for our total energy, we just added these three energies, which we have here. For the while loop here, we have that our time is 9.524, which was obtained through Tracker, and we updated the force of gravity, which is negative. The negative mass of the object times the gravitational constant in the y direction, and we have the spring force, and also here we have that the F net is F graph plus the F of the spring, and we updated the Newton's position update and velocity update formulas in here. And since we have these equations and we are updating the position and velocity, we had to update the spring conditions we previously had here. And to identify the changes in energies, we calculated basically just doing the final minus initial, and for each of the energies, and for the total energies we did the same, calculating the total final energy minus the total initial energy. Here is a video which includes part of my results for the predicted versus experimental model. As you can see, the blue ball and red ball follow each other closely, meaning that the results are accurate for the experimental and predicted model. However, we notice that sometimes you can see when the blue ball and the red ball are separate from each other. Here are the graphical results of the experimental versus predicted data obtained from the computational model. For the change in energies graph, you see that the change in energy is zero, as we anticipated, since the energies cancel out. Also, the x and y direction graphs are accurate, but have some errors. These errors could be due to the miscalculations in Tracker and not taking into account other forces, such as air resistance. For the first question, we do know the energy principle is satisfied. Since all of the energies were placed in the system, the amount of work done by the surroundings should give us zero. Here in the image, you can see that the change in energy is a straight horizontal line, indicating no change. For the oscillation periods estimate, we calculated it in the y direction using our data from tracker and in the x direction. There is a significant difference between the periods of oscillation in the x and y directions. If the period of oscillation in the x direction was chosen, our results would change since we are using the y-axis for the motion of the spring, and since our k and relaxed length would change, meaning that our forces would be very different.